Hello students, and welcome back once again to CSC 151 Computer Applications. In this video, we're going to go over if statements. Now, I already have some of these if statements already written, but let's just, delete these and delete these. Why not? We'll just start from scratch here. So I have a series of numbers that are just completely gibberish numbers. They mean nothing. I just wrote them down as examples. So we're used to doing something that has basically a grand total of one possible outcome. If I say if I say equal sum this guy and this guy, it's literally going to be only one possible answer, the sum of 15 plus 24, which is 39. If statements are slightly different. They have multiple possible outcomes. So if I say equal if, and, put a little parentheses there, you'll see that it's broken up into three things. The first thing is logic test, comma. The second thing is value if true, comma. The third thing is the value if false. There are two possible outcomes to an if statement. It is either true or false. So, if I say if, this cell is greater than 25, if that's true, I'll put true. I'll just say, if it's greater than 25, what would I like to say here? I'll just put a T for true, just so we know that we got to the true portion. And then comma, the value if false, I'll just put a F here for false. Now, the quotes around the T and the F matter, because much like how this is the start of an if statement and this is the end of an if statement, the quote right there is the start of a string, and the quote right there is the end of a string. It's telling me where my text starts and ends. This is where my text starts and ends. So obviously, if the 15 is greater than 25, in theory, it should skip the true value because this statement is not true. 15 is not bigger than 25. So I should skip the T and go to the F. So if I hit enter, boom, there it goes. There's an F. But if I do the same thing over here for, say, this guy, equal, do the same sort of equation here, equal over 25, comma, T, comma, F. Here we go. This one, whoops, what did I do? Problem with your formula. Your sum says blah, 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 blah. Oh, okay, whoopsie. I forgot to put the IF for if. So if B5 is greater than 25, which it is, in theory I should get true. If not, I should get false. And I got true. And of course, if I just go and stretch this along like that, I get false, false, true, true, false, so on and so forth. And that's generally how this winds up working. So there's three things. There's the logic statement, what happens if your logic statement is true, and what happens if your logic statement is false. So there's that. Now then, let me make some different example here, and I'll name these grades, why not? And I'll say, I'm going to say this is a 88, this is a 90, this is a 57, 78, 82, there we go, good enough. Good enough, I got grades right here. So, matter of fact, let me make these percentages. Whoop, 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 whoop. So, let me make these percentages by doing 0.88, 0.9, 0.57, point that. Because, as we all remember from previous videos, 100% in percentage format is a 1. So, 88% is 0.88, 90 is 0.9, 57 is 0.57, so on and so forth. So let me go and just make some if statements here. Now, you'll notice ifs, this one has an S on it, so equal IFS. Now we have essentially an unlimited number of possible things we could do. An if statement only allowed for two options, true and false. Ifs with an S will allow for Actually, I believe up to 256 possible combinations, but there's no way you're going to use all 256. So, I'll do something like this. I'll say if, and it says logic test 1, comma, value if true, 1, comma. So I'll say if this is greater than 90, I will put an A. So that's my value if the first thing happens. If this 88 is greater than, oops, let me do a 0.9, it'll say A. And let's see if it'll say A. It does not. There's nothing available. So we know that's not true. But then I can just simply add another comma. Now I have another logic test. So if this guy is greater than 80, which is a 0.8 in decimal format, David, I'll say B. So I'll do boop, boop, boop. There you go. Just visually so everyone can see the separation between it. Value my logic test 1, value if true. You notice there is no value if false. I now have a second logic test and a second value if true. And if I were to make a third one, this would now be a third logic test, 0.7. And this would be another, value if true. And I'll wind up with something like this and says, boom, and it wound up with B. Now, the order how you do this is matters. So, for example, for this guy right here, this 88%, I tested to see if it was bigger than 90%. That's what I checked. Then I also checked if it was bigger than 80%. And then I also checked if it was bigger than 70%. Now, these are not actually accurate to the mathematical variations of what counts as an A, what counts as a B, what counts as a C. I'm just using nice, big, giant, rounded numbers just to make a point. If by any chance, hint, hint, wink, wink, nudge, nudge, you see this in a future assignment, you're going to have to actually use the actual university-approved grading method where, 94 is the cutoff point and so on and so forth. You're going to have to use the actual GPA standards, not just 10% going down. So, but point being, this matters, because technically if we look at this, D3 is bigger than 8, so it's a B, but at the same time, D3 is also bigger than a 7, so it's also true to say that C is true. So why does it say a B, but it doesn't say C? Well, that's because the first thing that happens is the first one that is counted. So, an if statement will only pick the first correct solution. If there's multiple correct solutions, the first one gets picked. So if I did this in reverse and said IFS, and I said this guy is greater than 0.7, and put a C in there, and then did that guy greater than, 0.8, and put a B, and then did if this guy is greater than 0.9, and did an A, it doesn't matter that this B is technically the highest value, because the first correct answer was the C. So it found the first correct answer and skipped the rest. So however you wind up making these things, you don't want to wind up making these things, in reverse, because, what happens if this was actually a 99? 99 is an A. 99 is an A, but because the A equation happens before these other equations, it's always going to wind up saying C. So, to fix this, maybe I should do, maybe if it's, I could do if it's less than 0.7, I could say D. If it's, I could do this in reverse. If it's less than 0.8, I'll say C. If it's less than 0.9, I'll say B. And then if it's, then I guess I'll put, the other equation of, if D4 is less than 1, I'll put less than equal to 1. Then I'll put a A. And it'll go and put an A. So I could do this in reverse by checking less thans in order to do that. Or I could go greater thans and wind up having it make sure that my highest value is the thing that starts it. As a matter of fact, I should probably put less than or equal to. Probably put less than or equal to, or less than or equal to. That's probably this whole sort of situation. Now, I could also extend this out to saying D's and F's here, so let me just do that, and I'll just make this a gigantic equation. If that guy is greater than or equal to 0.6, it's a D. And then, of course, for anything, if that guy is lower than or equal to, I guess, 0.6, because that I guess if I already have an equal to 0.6, lower than 0.6, I'll just put an F. And now if I just click and drag and, copy this format down, boom, there it goes. I've got a B, A, F, C, B, and all those equations wind up working with, stuff like that happening. Whoop, whoop, whoop. Once again, do not click out of a cell when you're inside an equation. Hit enter. And that's how ifs work. Ifs work with, first logic test, first result. Second logic test, second result. Third logic test, third result, so on and so forth. And the equation will find whatever the first correct result is, and then stop. And that's how an if statement would work in multiple chains of ifs like this. Now, I could extend this between, grades. I could do something like checking ages and, dividing it by decades or whatever. I could do all sorts of things, check the months and have a condition for months or something. It doesn't have to always be percentages and numbers. Point being is that I can have multiple possibilities in one cell based on the equation. And those equations will wind up changing, the minute I change my information. And you see now it says F, so on and so forth. So, and note out here, if you don't have ifs, because some versions of Excel won't have equal IFS, it'll have IF, but it won't have IFS. If you do not have that S, Google Sheets does. So let me just zoom into Google Sheets here, and I go and type in equal IFS, and, same logic applies. If this cell is greater than 5, I'll type, I'll type A. If this cell is greater than 4, actually 3, I'll say B. And of course, if this cell is, greater than 1, I'll pick C. And right now, there's nothing in it, but, the moment I put a 3 in there, boom, there's a C. If I put a 7 in there, A. The same sort of situation, the same equation will work, same sort of logic format. Condition 1, the value 1. Condition 2, value 2. Condition 3, value 3, so on and so forth. And it will find the first correct value and then stop. So that's generally how this all winds up working. So, with that being said, that is the video on if statements. In the next video, we will be going under, we'll be doing some more formulas with if. So, here we go, and you guys have a great day. See you in the next video.